Glad to be joining you by Zoom. I'm sorry that I messed up the schedule, but here's my talk, and I'll be talking about traditional knowledge.
Yeah. I'm reaching that.
Okay. My name is Fikret Berkes. I'm at University of Manitoba in Canada. And start with a couple of words on traditional knowledge. It's becoming recognized by many national governments and international agencies, even IPCC, the Climate Change Agency. But of course, traditional knowledge has great significance for indigenous peoples and communities themselves. Outsiders often miss that point, and they think of just general knowledge that can be used for anything. And here, just quickly, it's been used as a source of biological knowledge, ecological insights, informs resource management, informs conservation, can be used in development, monitoring, assessment. It's a source of values and environmental ethics, which of course is an important point. But here I'm going to talk about traditional knowledge and its importance for adaptation to climate change and in dealing with disasters, reducing disaster risks. And traditional knowledge has a big role to play, but in fact, it's probably not appreciated sufficiently by people. So I pose the question, what can we learn from traditional knowledge? My plan and objectives are fairly simple. I'm going to talk about traditional knowledge as a source of resilience. And I'm going to make the argument that resilience can help with disaster risk reduction. So the plan is simple. First, a few words on traditional knowledge. Second, the concept of resilience. It's a technical area now. It's not just the dictionary sense of the word. And then we talk about how traditional knowledge can help build resilience. First, I'll tell you a bit about my trip, my one and only trip, 2008, to Cato Canyon. We went on a camp with some of the people who are at the conference. Here's what we saw as we came near a reindeer herd. And the herd moves, and herders monitor the snow conditions to help the reindeer move. It's really the reindeer who make the decision to move, but the herders help them, assist them to make the move. They move because as they feed in one area, they trample the snow and they make it difficult to dig through to lichens, which is their food, of course. So they need to move to a new area. And here are some herders helping the reindeer move to a new area. First, they have to make sure that the area is suitable for the reindeer. So they dig into the snow, make a snow profile, and in this case, the herder has found a couple of layers of crusting in the snow, but not very bad crusting. In other words, it won't prevent the reindeer from reaching the lichens. In the meantime, as they make the snow profile, the Sami herders are collecting some data for the government. In particular, they look at snow depth, 60 centimeters in this case, and they look at the ground temperature. There's a temperature meter at the bottom of that profile. So So it's their traditional knowledge, and it's people who are embedded in their environment, which gives them time-tested knowledge, and that's important for adaptation. Traditional knowledge often uses qualitative assessment. They don't do numbers, but because they do a qualitative assessment of, say, the snow depth, they can look at and assess a large number of variables. This is different from science, which uses quantitative data on a small number of variables. That point is really important, because if you're collecting quantitative data, you can't use a very large number of variables because the models don't work. So we call this fuzzy logic, which is actually developed out of engineering. It's a form of logic to deal with complex systems with a reasoning that is approximate rather than exact, because you don't really need the exact numbers to look at snow depth. Whereas Western science tries to put numbers on all the variables, and therefore cannot handle very many variables, and therefore science has problems with complexity. And of course, climate change is a complex problem issue. But using fuzzy logic allows traditional knowledge systems to deal with this kind of complexity, which is very, very interesting. So traditional knowledge, I define it as a cumulative body of knowledge, practice, and belief. And it evolves, it's not static. I define indigenous knowledge more broadly, and I define local knowledge as knowledge, but not multi-generational, not time-tested. The current international use of the term is by the IPBES, which is the biodiversity panel, and they prefer to use indigenous and local knowledge, ILK, and they actually use my original definition for traditional ecological knowledge. And it's being recognized as increasingly important in the context of climate change and related disasters. Now, using traditional knowledge in a fuzzy logic way to deal with complexity, you see in many different indigenous groups. The figure here is from the people I've been working with for years. These are the Cree hunters in James Bay, eastern subarctic Canada. And the question was, what are the factors affecting their goose hunt? Goose hunt is a big event. They get a lot of their food from wild goose. And you can see there are quite a few variables. If you try to put numbers on all of these, it would be almost impossible, and you can't model it because there are just too many variables, and the model sort of falls apart. The Cree recognize many variables, but also notice that there are factors affecting goose hunt, and it's not just climate change. There are other things happening, such as disturbance by helicopters, goose changing migration routes because of new reservoirs created in James Bay, and so on. So the figure was done by one of our graduate students, Claude Peloquin. And in fact, he has even a more complex figure than this. So the point is, knowledge holders look at the many things, great many things that in fact scientists do not and cannot look at. So we talk about indigenous ways of knowing. Indigenous people don't know climate change as a factual thing because they have not experienced it before. What they transmit to younger people is their ways of knowing rather than the actual knowledge itself. In other words, elders teach what to look for and how to look for things that are important. So Sami herders see many climate-related changes. They're looking at many factors, but they focus on this one critical factor, and that is freezing rain on top of the snow that causes crusting, which affects, of course, caribou feeding. But other indigenous peoples also use fuzzy logic to make sense of complexity, as in this example. This is a general figure, inspired the indigenous Australian saying, healthy country, healthy people. Many different indigenous groups have versions of this idea that healthy land is related to healthy communities and people. So, and it's a different worldview from science and general Western worldview. The key is the connectedness of people to the land, the close relationship between the people and the land that supports them. I'm sure there are a number of sayings in Sami that capture the same kind of idea. The important point here is the interdependence of the land and people. So for the Australian indigenous people, country means land. It's really the ecosystem. And if it's healthy, it gives healthy people. And if the people are healthy, they look after the country, they look after the land, plants and animals. So the health of the community depends on having a healthy land and vice versa, the other way around as well. So this close connectionship allows observations on changes that happen on the land, including climate change related ones. There was an article in 2016 in Nature Climate Change, which had actually published observations of over 1,000 climate change related observations along the entire world. You can see there are quite a few observations in northern Norway, but in fact, even larger ones in parts of Africa, the Himalayas, the mountainous areas, including the Andes. And this was in response to IPCC, the climate panel that said, well, indigenous observations don't really count. So somebody sat down and actually compiled them. And it's 2016. And after that, there have been so many additional ones that nobody has a count of it anymore. On Africa alone, there are 2 volumes of local observations that were published this past year. And by the way, these are not all indigenous peoples, but these are people who live off the land, who have a land-based economy, a subsistence-based economy. So, just a word of caution, more to the outsiders, the Sami already know this. Traditional knowledge is essential to deal with rapid environmental change because it provides information on the ground. People see, people observe changes. But traditional knowledge has a cultural context. Remember, we defined it as a body of knowledge, practice, and belief. The belief part creates problems for scientists. And traditional knowledge is sometimes dismissed by scientists and governments because it has a belief component. But I would argue that Western science also has a belief component that you can. Anyway, we won't get into philosophy of science, but it's based on the idea that if you have enough data, you can answer all problems scientifically, and you cannot. So that the belief in Western science, in fact, has some flaws. The point, however, is that there's a politics of knowledge. There's always going to be power differences between traditional knowledge and Western science, because Western science has many practitioners, big budgets, and they provide the information for governments. And traditional knowledge often does not, even though it's being recognized more and more. So what can we do? How do we talk about the two kinds of knowledge together? If you try to synthesize the two kinds of knowledge, it's not going to work, because science is going to basically pick and choose traditional knowledge out of its cultural context. So we've been talking about the concept of bridging knowledge. Traditional knowledge retains its integrity, but it has a dialogue with Western science, a partnership with Western science. So instead of integrating knowledge, which can lead to Western science co-opting, basically a colonial co-opting of traditional knowledge because of these power differences, we respect the integrity. This is what we talk about, respecting the integrity of each way of knowing, and keep traditional knowledge for adaptation and resilience, but through bridging knowledge to help enrich knowledge. And the other term often used is co-producing knowledge. This is a paper from Maria Tango and colleagues, my Swedish colleagues. Now, we talk about resilience. Briefly, resilience is the ability to respond to change. A more technical definition by Brian Walker and colleagues, it talks about resilience as the capacity of a system to absorb disturbance and reorganize while undergoing change, so as to still retain essentially the same function, structure, identity, and feedback. So this is a systems definition of resilience, and it's about the system retaining, a system being an ecosystem or a social ecological system. Briefer definitions: resilience is the ability to persist and adapt, which has been used as a definition. Resilience as the capacity of a system, such as a community or a region or an ecosystem, to deal with disturbances, let's say climate-related disturbances, in a way that leaves the system better prepared to deal with future change. So it's future-oriented. Now, we're getting a bit technical here. So resilience is considered to include coping capacity, adaptive capacity, and transformative capacity. And all three add up to resilience. And this is based on some work by Christoph Bene and Kate Brown in UK. So this coping capacity is basically the ability to persist. Adaptive capacity is about flexibility. It's about incremental adjustments. And finally, the transformative capacity, which we won't really talk about, but the ability to transform into a different system. How it works is about the intensity of change. For example, what climate change brings. If it's a small change, you have a coping response. If it's a medium change that forces adjustments, you have adaptive response. But if it exceeds the ability of your system to deal with it, for example, if the area, I hope never happens, but if your area gets so much crusting that it becomes impossible to keep reindeer, then basically you transform into a different kind of economy, which is no longer based on reindeer. So, but we'll leave it at that. So all these three areas add up to resilience. You can think about resilience in this way. If you have a stable, resilient system, it can cope with shocks and disturbances the ball is in a cup, it moves around, but it's stable. It's a resilient system. However, in an unstable system, the ball moves out of the cup past the threshold, a threshold into another cup. And that's an unstable system, and it results in an alternate state. That we don't want to happen. We want to keep the ball inside the cup. We know it moves around and we know it's going to adjust, but it stays in that stable area that we want it to stay. Well, why is it important, resilience? There's a lot of theory behind all this that, of course, I can't get into here. From the point of view of dealing with disasters from climate change, resilience is important for 3 reasons. One, resilience helps look at hazards and risks holistically, the way indigenous people often do, and the way that Western science often is unable to do. Holistic approach, number 1. Number 2, resilience puts the emphasis on the ability to cope and adapt and still retain the same system. So a disaster, people often can deal with it by coping, making small adjustments, or adapting, making bigger adjustments. And that's really important. And that's based on knowledge, of course. So that's really important, the second point, coping and adapting. Third, it's really important because it's forward-looking. It leaves the system better prepared to deal with the next kind of change. And of course, to explore policy options for dealing with unpredictability. We often talk about adaptive management that based on social learning. And indigenous people are very good at that. So that takes us more specifically to the point about how traditional knowledge helps build resilience. Again, 3 points. Traditional knowledge increases the range of knowledge available to solve problems. Western science is not doing a very good job in solving problems such as climate change. I mean, we know this. So we do have problems, and traditional knowledge helps deal with these problems. Second, traditional knowledge is like a big encyclopedia. It's a source of adaptive capacity. It provides the raw material to make new adaptations. And the third point I've already mentioned, co-production. Traditional knowledge, when it's shared, when it's dialogue with science, leads to collaboration and social learning from experience through co-production of knowledge to deal with problems and build resilience. So I expand on these 3 points. One is expanding the range of knowledge. Well, of course, traditional knowledge is a source of on-the-ground information, like the Sami herders observing crusting in the snow. Traditional knowledge provides a time depth of observations that science doesn't usually have. In other words, it produces a baseline. Scientists like the idea of a baseline, but they often don't have the data. Well, traditional knowledge does have the baseline. Traditional knowledge also helps monitor change. So it's on-the-ground information, but you monitor changes as they happen, as in that big map I showed you, where communities all over the world are monitoring these changes. But also, this knowledge helps understand the changes, understand the ecosystems people are living in. And it leads to, in fact, it helps science because it create some scientific hypotheses that scientists can go and check. We've done this in the Canadian Arctic. It really is important. And scientists have been learning from Inuit and other northern peoples on making and testing hypotheses when they have this combining of knowledge. As a source of adaptive capacity, it provides the raw materials for adaptations, yes. But more specifically, think of examples. For example, the potato park in Peru, which is controlled by the local Quechua indigenous people, it has over 1,000 varieties of potato. So with climate change, it will become important. Canada, for example, plants 4 kinds of potatoes. With climate change, some of these are not going to be usable. Where do you get the new varieties? Where do you get the new genes for potatoes that will grow under the new conditions? Well, they have to go to the potato park in Peru because that's where the source is. That's also the origin of potato. Sami herders' knowledge of reindeer genetic diversity. Herders told me that a beautiful herd is a diverse herd. But the Ministry of Agriculture wants to make uniform herds, which is really a bad idea. So they have to learn from the Sami. Right now, there's a lot of work on coffee species and varieties in Africa. Basically, the world plants 2 kinds of coffee. And one of them is rapidly becoming very difficult to use, the Arabica variety. So now there's a search for new coffee species and new varieties, and Africa is the source. So these examples give you an idea on what the indigenous people know and hold as knowledge that's going to be important for adaptations, not only their own adaptations, but world's adaptations for climate change. This point about knowledge co-production is important. It's defined as the collaborative process of bringing together a plurality of knowledge sources and types together to address a problem. So it's problem-oriented co-production, but it's talking about the plurality of knowledge. In other words, not somehow mushing all the knowledge together, but keeping and recognizing the strengths of different kinds of knowledge in solving problems. This is the idea of bridging. How do we do that? Well, through collaborative networks, knowledge sharing partnerships, which lead to social learning. Now, social learning is a crucial issue for problem solving, and we published on this, specifically looking at climate change related hazards, which are unpredictable. Social learning allows you to use your last experience to deal with the new hazard, the new experience. And that is adaptive management. That's a technical term. We talk about learning by doing in policy, and that's adaptive management. We have to have learning by doing, because the fixed solutions do not work in unpredictable environments. The political scientist Oren Young has made the argument that you need to bring in new experiments, innovative practices, indigenous knowledge to make new practices, innovative practices, when you have uncertainty, such as what we're seeing now with climate change. More on knowledge co-production. I showed you the Sami slides. They're monitoring the snow, but the Sami herders' own monitoring is fuzzy logic. They talk about snow being hip deep, knee deep, or ankle deep. Whereas the government monitoring wants to know exactly how deep the snow is, say 60 centimeters, and the temperature at the ground level, let's say -5. So these are looking at the same observation, the same kind of system, but two different kinds of observation, really. And that's co-producing knowledge. I think the traditional knowledge is superior in that it's a descriptive language, which is, in this case, all you need. So to co-produce risk knowledge, we published a paper on this with Raul Lejano and others. This co-production relies on indigenous and local knowledge. It relies on social learning, but also relies on communicating in plain language, which Raul calls narrative ways of knowing. So it's going to be important as climate change, it's going to get worse. There's no doubt about that. It's going to get worse, and the scientists and government people have to learn narrative ways of knowing and plain language communication, and you can help them do this. They love jargon, but you don't need jargon. We're doing fuzzy logic. We have to deal with many variables, and we need to use plain language communication so we can do co-production of knowledge. So I move to conclusions. Recap the main argument. Indigenous resilience is what I'm looking for. And this is the ways in which knowledge and learning, along with the broader political ecology, all these relations indigenous people have with the state, with the government, they determine how indigenous people understand and deal with and adapt to environmental change. There is such a thing, I think, as indigenous resilience, because indigenous people have been resilient. They have learned to be resilient over the years, much more so than other kinds of people. Other kinds of, let's say, urban people are not really resilient. When they had a heat wave in Paris a few years ago, 10,000 people died from the heat wave in the city. So indigenous resilience has a lot to teach. Traditional knowledge is a source of this resilience, and resilience can lead to disaster risk reduction. So the main argument, resilience building, learning with traditional knowledge, and adaptive management is a very good way to respond to climate-related disasters. The big if here is that healthy people, healthy land. People need access to the land to make the land healthy, and the land makes them healthy. So people, indigenous people, need land and resource rights. They need secure land and resource rights in the first place, and then they can develop indigenous resilience. If they're cut off from the land, or if they don't have rights, they cannot do this. Now, in the Sami case, we've only talked about crusting of snow, but remember, there are other impacts of climate change, and they include temperature anomalies, extremes. There's a famous case in this Inuit community I worked in. It got so hot in the summer, they went water skiing in their power boats, water skiing, just as a fun thing, and they recorded it in video. You have changes in predictability of weather. This is a big issue in Northern Canada. Indigenous people say they cannot predict the weather anymore the way they used to. It becomes unpredictable. You can't tell what kind of weather is going to come tomorrow or next week. And they used to be able to do that. Changes in the seasonality. When the rains come, is a big problem on the west coast of Canada with indigenous people. The rains are coming at the wrong season. The snow is coming at the wrong season. Freeze up, break up, coming at the wrong season. You might have too much rain or too little rain. Africa suffers from that a lot. And drying of surface water and groundwater, this is big issue in many parts of the world, including Southern Europe. Phenological changes, timing of flowering of plants. I added changes from tundra vegetation to bush. In 2008, people kept saying tundra, but I kept seeing bush between 1 and 2 meters high until Sven explained it to me that in fact, plants have been changing. So finally, adapting to climate change, as well as other disasters, requires traditional knowledge to build resilience, specifically indigenous resilience, which is something that the rest of the world can learn from. Traditional knowledge enables co-production, it leads to social learning, and it enables that adaptive management, learning by doing. You don't have fixed solutions, but you learn from the last solution to make new solutions. That learning by doing is characterized by rounds of testing and learning from experience to inform subsequent practice. And I should add government policy, because government policy is often very fixed, not flexible enough, not resilient enough. So indigenous people need to, and are capable of telling, informing, advising government. And in fact, the Canadian Inuit have in part done some of that. Many of us are here, are practitioners, herders. Some of us are from universities, and I hold universities responsible and capable of becoming partners in knowledge bridging, developing local capacity, helping with communication, and supporting local institutions. So that's I'm not a herder practitioner, but I'm trying to be a good observer of who can play what role, and my role has been trying to understand some of this. So with that, I thank you, and I acknowledge some of the research collaboration that has led to this work. That includes my Canadian colleagues, some of my Sami colleagues, some of my colleagues in Australia, New Zealand, and in fact Taiwan recently. And my project support has been from Canada Researchers Program and others. Thank you.